Yeah, that's enough testing. Oh fuck, where's my OBS? Hold on. Okay, there's the tab. Alright, yes. So, it is time, as they say, for doing more Lisp. Cause, yeah. Um, so I think last time in here I can actually, let's go ahead, yeah, let's pull something up on it really quick. So something I was working on a little bit last time was, just generally getting here, let's open up an Emacs as well. And wrong folder. Wrong folder. Okay. Okay, here we go. Yes, this is it. This is the right folder. No, that's the wrong folder too. Fuck. I should not call everything bug, maybe. I don't know. I feel like it's kind of my brand, though, so I still do. Yeah, let's pull it up over here, actually, so that I can... Alright, so where were we going? Fuck. Yeah. So this is a shitload of code that doesn't really, in and of itself, like, do anything spectacular. That being said, kind of just a lot of it's like going through testings. And what I'm able to do now, I've learned, is actually, here, let me unfuck some of this so that I can give a decent enough example. So last time it was sort of getting the last little bit of the code generation for a listener connection well generated, and it's done. It's done, question mark. That's how I will describe it. It is done, question mark. We're gonna want to get a Sly instance here, and let's just go ahead and process all of this. Alright, beautiful. Oh wait, we don't need to process all of that because we're already in a package. Okay, let's just process all of that because that does need to be processed. Set some of these. Alright, and we're going to ignore this one. We're going to ignore this one, and the reason why will become apparent in a little bit here. But what we are going to do is, let's go ahead actually and comment all of this out. Yeah, I've kind of been using this file as, I guess, like a fucking playground for figuring out everything that needs to be done. But, it works. Alright. Like, we are actually fucking getting there, which is, whack as hell to me, for lack of a better way to describe it. But let's go ahead and get a terminal. We're going to want a terminal for this. Alright. And yes. Okay, here we go. Alright, so we'll go ahead and load that, and we will do make display. And what this is going to do is it's going to run a Wayland display, and there, it's going to lock because it's running. But now that that's done, what we can go ahead and do is all of this uncomment. Alright, beautiful. Okay. And yeah, this is kind of the, I guess you would say, I don't know, proof of concept. That's what I'm gonna call it. Alright, we have Wayland 0, perfect. And we're gonna want to connect to Wayland 0 in this instance because Wayland 1 I will touch on that in a second. But Wayland 1 is fucked up. Alright, so we got a pointer, and that's going to be our client, our connection to the display. And we also have a valid pointer for the registry. Okay, cool. And then a protocol listener object. Now this part, I still pass it in. I'm still gonna pass it in, but it doesn't work. I should clarify. And that's sort of on the subject of what I'm going to discuss next. And then yeah, 0 right there for adding the listener. And then this is sort of the proof that we, in fact, did make a connection. So, the Wayland client display round trip, what it does is, just to give a bit of a quick overview without, like, jumping into the source code for it, like the Wayland source code for it, because it's fucking paragraphs, because, you know, it's C. But, to kind of go over it really quick, what it does is, it sends a request to the display, and it blocks any further input until it receives a response from the display server. So, I mean, it is literally a round trip. But yeah, 2 is the number. Fuck, we are going to go into the source code because I can't remember what that number represents. But, yeah, we were going to have to jump in there anyway. But yeah, this is officially connected to this display right here. I think this is the number of global objects, if I remember correctly. Let me go there really quick. List test.c. I believe that this is in the, it's in source. I do know that much. And is it client.h or client.c? Alright, I think it's the .c file. Yes, okay. Here we go. So yeah, block until all pending requests are processed by the server, and then it returns the number of dispatched events on success or -1 on failure. And so the dispatched events are, where are you? Where do you live? These two right here. These are our dispatched events. The global callback, or like the Wayland registry global and Wayland registry global remove. And so the listener, the registry listener, is in fact able to, you know, understand and dispatch to the display those two callbacks. What it's not able to do is fucking run them. So I had this set so that it would look, or generate an out.db file, because I thought that I was just having a format error at first. It does not. There is no out.db. This is not something that gets generated. If you can see kind of from the debugging text as well, that's sort of further evidence that I couldn't get this part to fucking work. What's more interesting here, we can go ahead and disconnect the server now. That's going on down there, and we're not going to be safe about it. Honestly, it's just going to disconnect it, and I'll reboot my computer so the socket disappears. You know. But yeah, what we're going to do is let's go ahead and kill this. Yes, bogus stock frame. I don't give a shit. Okay, not quirt. Quirt. Okay. And then, let's see if we get an error thrown. We should. Or a nil. Yep. Okay. So that works. What doesn't work is, let's change this to 1. So one is, in fact, the server that my window manager is currently being run on. This is Wayland 1 is the name of the server. I'm running Hyperland at the moment, so it's a Hyperland server. But yeah, watch this. So we run into an initial error. This happens every single time, where we get if you look right here, unhandled memory fault. And you are able to just go ahead and retry, and then type this in. Display round trip, display. But then it hangs. I originally thought this hang was I originally thought that this was actually due to the fact that it wasn't able to print the output. I thought that's what was going on. But if we look back here, actually, where are you? Rereading this. Block all pending requests until all pending requests are processed by the server. So it's fucking blocking. It's not processing the request. So we kind of have two problems there. On the one hand, the callbacks are being passed down, but they're not being triggered. I have to figure that part out. So that's like hump number one, I guess. But whenever we do define our own server, we are indeed able to connect to it, so that's pretty sick. Because really the server-side stuff is the main part I want to work on, but, kind of getting both the server and the client going was... I do want a complete package for this. I want this to be something that, even if it, takes me like a year or something like that to finish, I want this to be something that others are able to use. I want this to be kind of in the same vein as, like, the Pi Wayland roots or Smith A or something like that. We'll see if we get there. I mean, we are going to get there. I am confident about that. We'll see how long it takes, I guess, is a better descriptor, if you would say. But yeah. Anyway, that's kind of a digression. The point here is that, indeed, we are able to connect to our own established server. It's kind of a bullshit server that only has, 2 events being passed to it. And then we are blocked whenever we try to connect to this one. I'm not sure if it's because the protocol is different, because Hyperland's kind of weird as hell like that. I don't really know. I don't know. But I'm pretty sure that the issue is that the way the display is being defined currently on the client side, or even just it's not able to access the listener like the server side since it's defined differently, since I didn't write it. But yeah, we'll figure out that piece of the puzzle some eventually, soon, definitely soon. Kind of, as they say, I guess, like cart before the horse. Trying to get the client built right now whenever a lot of the code base still needs to be worked on, like a lot of the primitives and everything. But to give an idea of what this is supposed to do right here, we can actually go over to an example from the C. So let's go. Where are you? Alright, fuck.c. Yeah, that was it. So if we fuck this, look, yeah. It, actually prints the interfaces, the versions, and the names. So there's some sort of mismatch going on here, I guess is the best way to put it, Something is amiss in my own code. Not too sure what just yet. Why? There you go. Okay. But we will figure it out, as I say. as I am saying right now, we will figure it out. What I want to kind of focus on a little bit right now, though, is, as you can see, word of the day, I guess you could say, is tests. Because I am working on some of the unit tests again. List test dot list. Yeah, because that's where we want to live. So Wayland actually has a pretty robust amount of unit tests. If I pull this up and go over into the tests themselves, even, there's kind of a shitload. And I don't know. I mean, I personally, I like unit tests. I like tests. I kind of like being able to see that the shit works the way it's supposed to work. It's probably, I like it about as much, if not even a little bit more, than the actual banging out the code part. Like, I love the tests. I love the tests. I was a Project Euler nerd, for lack of a better way to describe it. That is most of how I learned, like, my initial C, whenever I was learning C. Hold on, let me take a sip of tea, 1 sec. But yeah, whenever I was learning my initial, like, working with C, it was all Project Euler was the big one. A little bit of advent of code, but I never did elite code. I still have it. I never tried to get a job in the shit, so maybe that's why. But yeah, there are a lot of tests here. So like, if we take a look at, for example, the resource test, I think that these are not the resource test. I don't give a shit about that one. Well, I do give a shit, but test compositor, yeah. Here's a good one. Oh, it's a long as fuck one, but yeah, they have some very robust test setups. So like, there's one for a compositor. There's one up here for a client, even. There's interface test. That's the one I was looking at earlier. There's one even for interfaces. I believe that the issue I'm facing is an interface issue right now, because for whatever reason the underlying C interface is not being passed along to whenever I use the Lisp functions. It's a bit of a guess. A bit of a guess. But this is like one example of one of the tests, one of the more fairly basic ones. I'm kind of working through these as well as a means to complete some of the code that I've been neglecting for like some of the primitives. What we've been working on a little bit today has been the lists. I'm not going to pull that up because it's on the other screen. But then like another one, for example, is arrays. I don't think I've written shit regarding arrays. I don't think I've done it. I probably need to. These are used a lot in the core Wayland protocol, so even if I don't end up using them directly in like writing a server or a client, it'll be good to understand what the fuck they're doing, because they are weird as hell sometimes. To my knowledge, though, the arrays are basically the same as a Wayland list, except they are of a single like size, you know, like a regular C array. But yeah, it's been test time. Most recently, for example, I have a couple already written for the Wayland list, since that's kind of like the most basic data type that you can work on. And yeah, if you look, we do indeed pass our tests, which is always nice as hell. And these are some of the more basic ones. This is literally just testing the initialization of a list and the insertion of a list, the list length as well, and I don't know what iterator is going to do yet. We're about to find out, I guess. But yeah, to ensure that these, you know, do what they're supposed to do, I guess, for lack of a better word, we end up calling, these are just very thin, this one at least, The remove and the insert are a little bit bigger because I'm also handling the slot allocation of the Lisp objects as well as like the underlying like structs. So they're a bit bigger, but at the end of the day, they just return. But they're also, you know, kind of like, this is the only one that interacts with it directly, and we're just testing struct pointer quality. So we are again fucking with the underlying C code for validating those tests. But yeah, a lot of these literally pass off the same value that the actual C code itself does. Like if we, let's go into the util really quick. So if we take a look, for example, at, let's see, there's some of the, yeah, that's remove. It's kind of a handful. It's kind of a handful because of the way the original code is set up, and the fact that, unfortunately, like, since we're dealing, at least kind of like as this FFI is being defined, since like on my end I'm dealing with the pointers and shit still, I have to make sure that those don't, I don't know, put the end user in a way that's going to like fuck them up. I kind of want to hide all, abstract all of that away, but like I have to deal with it, I guess. Which I don't mind. I don't mind. I write C for fun, so yeah. So yeah, these are a bit more of a lengthy ones, but like if we look at Wayland list empty, we quite literally just return a check of whether or not the slot value for the underlying C Wayland list is empty. Like that's all we do. Yeah, same thing. Length is once more a literal passing of that underlying C struct. So if these unit tests pass, able to say with able to reasonably say that my actual code is doing what it's supposed to do as well. So I'm hoping that as some of these get worked through here and there, you know, going to begin to understand a little bit more of what's going on, I guess, of where I need to make things a little bit more improved on the client server side, but have to learn, what's the people say, have to learn to walk before you can crawl, right? No, it's the other way around. But yeah, we will go ahead and get started with some of this. So what the fuck does this test do? Okay. Why are we storing an array of references? Why not just, I don't think that that's, you know, a big deal. I think that we can just go ahead and, how did I define this element? Because it's been a little bit. Okay, test file. All right. So we'll start with, and so we'll start with a list, and then we have how many elements, so yeah, I'll just do E1, and then our test element. What the fuck is that value? I'm sure they had a reason for these. Probably not. Okay. I'm gonna go ahead and use it again nonetheless. And we will do, alright. 2, 3, 4. Perfect. And then, let's see for this next one. 10, 20, 30. Oh, okay, they're kind of pointless, I think. I see now. 70, 80, 90, 10, 20, 30. And then, I don't know. I don't know if either of these are like a reference or just might be overthinking it a little, you know? I'm pretty sure that it's been a while since I've actually looked at the Lisp code, so oh, it's list in it. Alright, so I do indeed call that the initialized instance. That's what I thought, so we shouldn't need to do that. What we do need to do, though, is and really call, or you can name it whatever. This stores the, so if you look at Wayland list, it is an object. And like shown here, it is a Lisp object because I found that that was indeed the easiest way to, you know, get it to behave itself. I think this was the first thing I wrote at the very start of all of this. Yeah. Yeah, no, it was the lists. Defining them, they were the very first object I defined. Even the actual Wayland object up here that it inherits from came after it. This thing is pure hell. This thing is pure evil, by the way. I'm not quite the fan of. I need to organize some of these. The order they come in, at least. Yeah, I'll do that later. I'll do that at a time whenever it wouldn't be boring to witness it. Yo, what the fuck? Get back over here. Oh, you're commented. We're gonna run into an error with this. Maybe not. We do want the method count initialized to 0, though. Same as the version, same as the event count. You know, get some actual init forms on that. Okay, cool. Perfect. Yeah. Here's one of the first things I wrote. I don't know. On some level, you know, I think I've been at this for like close to a fucking month. Let's actually see. Am I able to see the git log? Maybe. Alright. Initial commit. Yeah, so we are close to a fucking month. That's fucking insane. Shit, okay. Is it? Yeah, okay, oh god. Yeah, it's been about a month. Feels like way less time and way more time, but anyway, it feels weird coming back to these because I haven't thought of the Wayland list since kind of the initial writing of it, but yeah, I guess, you know, let's go ahead and, you know, work on this a little bit more. Alright. Get rid of the to-do and get rid of this as well. I think it's gonna have shy bars. Yeah. So let's see. Next, we want to just go ahead and insert them. So let's see. Wayland list insert, and then we're gonna have test list, and then we are inserting the first element. And I only defined that looks like a test value, so that's really all we do need, actually. Yeah. Because this link is well, did I inherit from Wayland list? Yes, I did. Okay, yeah, cool. I should have known. I was like, I must have, right? And yeah, I did. Okay, cool. I haven't touched these tests in a hot fucking minute. But yeah. Alright. So the first thing that we are doing is the test list, E1, and then we pass call. Yeah, we're doing E1. And then we do what is going on here? Huh. Okay. Okay. Let me see. What the fuck? So we initialize the list. And then pass the previous. Huh, this is rather weird. Are we passing it in backwards? Is that what we're doing? Hold on. Let me see. So, wayland list for each. I think, yeah, because we're passing in a reference, so hold on. Previous points to the head of the list in a single object list, right? Yeah, hold on. Let me, so, client dot, we're gonna hop in here really quick, and okay. Documentation time, I guess. Inline header documentation time. I used to bash the source code as the documentation, but I'm starting to get more used to it with this especially. I think maybe it's because the Wayland documentation in the source code is unironically better than like the actual Wayland book, in my opinion at least, but yeah, I don't know. Okay. See, on its own, an instance as the sentinel head of a doubly linked list must be initialized using Wayland list init. When empty, the head's next and previous members point to the list head itself. Otherwise, next references the first element in the list and previous refers to the last element in the list. Okay? So what we're doing here is perpetually referring. Okay. Oh, we're good to go. We're good to go. Okay. I think. Fuck it. Let's just do it. Let's just see if we can. 5, okay. And we need 4 of these, and each time we're just passing that. I wonder what this is gonna do to it. Do I have a wailing list for each to find even? No, we want to go to util actually. Util. Wrong one. Dot lisp. Okay. I might need to export this. A wailing list for each. Yeah, I'm pretty sure I need to export this. That's a test output. Oops. Too many things named test. Wailing list for each. And this is really just a do list wrapper. I think that's quite literally all it is. Oh wait, no, we don't constitute the head. Yeah, I forgot about that. So it's kind of like a do list wrapper, except we don't take the head into consideration. We only do the list. And that's because the head is not part of the list? Yes. That is what I remember. Yeah, no, the head's not part of the list. It's considered the list. So I guess in that case, they're like one indexed lists. Maybe is the best way to 0 indexed, but you literally don't count the 0 whenever you're counting the length of the list. I don't know. I don't actually know how it's done, like, kind of on the Wayland side of things, but yeah. Let's see, Wayland list for each, and the list is not cool. Element column results. So wait, forgot something. Okay. Are we just naming the element here? Yeah, let me... Okay, yeah, we are quite literally just coming up with a name for it. Okay. Yes. Let's see. That's car collection. And an optional result, so, let's collect res. So res, alright. Because we're going to want to know if either of these fail. I need to set that to nil, don't I? Alright. Now this is kind of interesting. Oh, we're going to want to return. Okay. There we go. I was reading this part instead of this part. Okay, here we go. Alright, so the first thing we want to do is just oh, hold on, my dog wants in my room. One sec. Right, yeah, come in. Okay. So I want to assert that there's an assert in Lisp? Okay, what does this do? Signals error if the value of the test form is nil. Returns nil. What does... Oh, wait. Alright. Sick. Okay. Okay, that's sick. Sending an error back isn't ideal, but it's probably the... No, we'll set it or the zitter. It or the zero, not it or the zitter. Okay, iter, and I think I can just set it a T, right? Yeah. I'll just do one. We just kind of need any non-nil value. Alright, so. So if not, well, we don't need a not, so we will do if greater and then array length reference is size of in this case it would be 3. No. I can't count, can I? Yeah. An array of 4 elements has a size of 4. I think. Okay, let me figure out what this, let me unfuck it a bit. Alright, so define array length, size of A divided by size of A0. So we are doing the size of the array divided by the 0th element of the array. Okay, so it is quite literally just the length of wrong language. Okay, there we go. Alright. So here we just need 4. We just need 4. I'm not actually gonna count. Else what we want to do is another if statement. actually, we'll just do 2 ors. That's probably a little bit more, actually take advantage of the things that Lisp provides us here. Okay, perfect. So, let's see. E pointer I equals reference. Huh. Wait, okay. E pointer I equals reference, array length, reference, okay. And reference is the name of the array being defined up here, I believe. Yes, 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 okay. Okay, okay. Yes. How did I find the E here again? Oh, it's I. Okay, that's why. So I guess we do in fact want to this is, no, no. Okay, I'm overthinking this. We've named the actual elements elm for the do list. I keep forgetting that aspect of it. We're inside of a do list. Alright, think like it's in a do list. Okay, perfect. I can do that. I can do that. Alright. That's a little too far down. Alright, perfect. Let's see. Alright, so equal test file element, and we are array length reference minus I minus 1. Okay. So we have an array length of 4. So let's say this is the 4th element here. So we're on I. Wait, no. Because there's 0 indexed. Okay. What we want to do then is actually do one more let that stores these values. Okay. Okay, yes. Ref. Alright. And then I think position is the one that we'd want to use. So sequence item. Yeah, position gets the trick done. Alright. We should just be able to equal it. equals reference minus I minus 1. So if we're on like the third I, which is the end of the list, this would say that E3, or like, yeah, this one, the third would equal, array length will be 4, yeah. So 4 minus I, so, wait. So if we're on like the third one. Oh, that's the reverse. I'm getting a little too ahead of myself. Okay. They look so fucking similar. God. Actually, we want to get the nth, I think. Yeah. So, nth elm. Wow, hold on. Yeah, okay. Okay. Hold on. Alright. I believe that this should work. And we'll just want to check that res is, I think we can just do check result, since, you know, we're setting it to nil. Alright, test conditions, undefined. Alright. Wait, not test, test file. What do you mean they're undefined variables? Hold on. Oh, okay. Oops. Alright. Okay. Always forget the fucking... I'm pretty sure I named this thing element. I don't know where I pulled test. Oh god, come on. Come the fuck on. Alright, go. Alright. Yeah, element. Perfect. Okay, holy shit. Equal normal state. Okay, thank God. Alright. Head is undefined. Is head the only one that's undefined? Wait. Oh, defined but never used. But yeah, that's because I don't know if I need to use it. Okay. I thought I was saying it was undefined. Alright. Let's see. Not of type real. Let's just not type that. Yeah, I'm starting to get kind of frustrated with types overall, but what do you mean it's not of type real? Alright. Hold on. Wait a second. Wait a sec. Okay. That was it. I'm pretty sure that was it. No? Is not of type list. Now it is. Wait, ref is not of type list. A res? Or should we also macro expand this? this ought to work, I guess. Yep, passed. Okay. I think so. What if we set it to... zero? Just to double check that. Okay, cool. So nothing is being executed in the when loop. Okay, perfect. Alright, and so we can clearly assert that that's correct. You know what's actually probably a bit cleaner now that I think about it? We can actually get rid of this whole fucking res. Alright. Okay. Yeah, we can get rid of that. And let's just... check that. Oops, alright. And check this. The question is, since it's inside of a macro already, is it going to give me a fucked up result? But I guess we're about to find that out. Let's see, so, illegal function call. Wait, what do you mean illegal function call? Hold on. What is the illegal function call? What? Okay, hold on. What's going on here? I'm not gonna... We'll see the error. We'll see the error. I'm going to assume that it's okay until then, you know? Unless, yeah. I think that was an old error, maybe? Yeah, I hope so. Okay. Fail. Okay, so we're failing there. We'll do length ref. Alright. Check length ref, and... Nth iter ref, I minus 1. Okay, and let me see actually. What if we pass it as equal? Still fail. Nth is nth in lisp. Alright, hold on. Let's see. Oh wait, now my dog wants out of my room. 1 sec. Yeah, okay, in and out. Alright, let's see. List iterator. I wonder. Let's go ahead and, you know what? We'll go ahead and format the Alright, let's see. Oh, fucking course. Alright. Yeah, let's... Alright, perfect. Let's see this. Where are you? There you are. Well, that is weird as hell. That's weird as hell. That's weird as hell. Hold on. Hold on. Fuck. Okay. I think I might know what's going on. Maybe? Maybe. Let's see. We're passing this in reverse. We're passing this in reverse style. Okay. That's weird as hell, though. Alright. Probably because I'm pushing it onto the stack. Yeah, that would be it. So what we actually need to do is reverse this one, and probably unreverse the other. Yes. Yes. Probably. That would only make sense, I think. Oh, that's my music. Alright, test.lisp. Right? Right? 'Cause I'm not putting this shit in backwards. But this is getting passed to it backwards. I mean, it passes now. I wonder. This is weird as hell. This is weird as hell. Okay. I thought that I had fixed this already, but I guess not. Let me go back to the utility functions for creating the list. Alright. Wayland list insert. So first we check for an empty collection. If empty, we push new list to the collection. Alright, these are all setters. Push new Kadir, end Kadir, position, list, call. Fuck, that's kind of a mouthful, but... Alright. So we push this element to the Kadir of the collection. Wait, hold on. So we push this element to the Kadir of the nth Kadir of the position of our other element. Okay, so that's pushing it after this element. So we do, that part is sound. The list should not be backwards then. But since we're sending this in, oh, okay. Since we keep pushing, you know, we're pushing this in backwards. Is the way. Is this what we want from the list test.c? So have to see if this is the actual expected logistics there before we fuck up the list for each. Right, so this would initially be pointing toward itself. And then we add a Wayland list into there. Alright, hold on. Let me actually see. Util. Alright, so walking through this, whenever we insert a new one, the first thing we do is set the previous and the element to the link. So this, and yeah, I can go ahead and let's walk through a basic edition here. So e1.link prev would equal list, and then its next would list equal the next to the list, so it'll be pointing to itself. And list.next will equal element. Since we're passing list.previous, you know, in this one it would I don't know. This is because we're passing. Yeah, let's see. Yeah, let's go ahead and check this one out. All right. So. And then, the next element in the head of a list is itself on an empty list, so right? Yeah, this would be alright, and then the next in the list So the next element of the list would equal the element. So pointer prev next. This is rather interesting. Okay. I wonder why they did it this way. That's really, really. Let's look at the documentation for a Wayland list for each really quick. Alright. Where are you? Here we go. Define Wayland list for each position, head, and member. Alright. Position equals Wayland container of this works with Wayland container of or under the hood. Okay. For position equals Wayland container of head, next position member. And Wayland container of just gets the next part, or something contained within the, I believe, yes. Alright, so return the container for a specified pointer. So this okay, so the first element of the list equals whatever is the next for the head. Okay. Alright, so, okay. Alright, cool. So that part actually functions as it should, I guess. And then we just pass it on again, and we do the body as well, but oh, sorry. This is rather strange though. Hold on. Okay, let's see. Let's test out Lisp. Okay. We're pushing it in backwards, because what's going on is we keep pushing this after test list over and over, which we don't want to do. How would one emulate this behavior properly without reversing the reversal? Gonna do one last thing. And just, I guess, like a small sanity test for myself. List iterator, okay. Yeah, it's going in backwards. So I'm calling this incorrectly. Let's fix those first before I forget. So, list this. So the issue is in how I'm calling this logistically, I think. I think it's because I'm working with a collection, or using this to track it, is what I'm saying. I mean, logistically, this is how it should work. I believe so, let's see. Yeah. We're gonna count that as victory by technicality. Let's see, so that's that on that. And then we want to do the reverse, which also needs to be added. So let's go ahead and count that. I don't actually know if I need this, since we can access speed pointers easily, but kind of for historical reasons. And by historical reasons, I mean, oh, the fuck, okay, here we are. Alright. Alright, so now we're doing the reverse. Let's see. My list for each reverse is the same exact, except 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 we're gonna have to set the error back to 0. Yeah, that's my except. Alright, let's see. This is a quite roundabout way to get the length of an array. E-I equals length of array minus I minus 1. So, for example, third item has to equal so 4 minus 3 minus 1. So E3 has, no, okay, brain, yeah. 0 indexed. But this part isn't, because this is going, 0 indexing is gonna fuck me over sometimes. But so is non-zero indexing. It's because the lists don't feel 0 indexed because we're not constituting the head. And that throws me off so much. let's just do the really convoluted C version that they have defined here. Because, you know, why not? Although, I mean, we're not gonna do that. That's why. We'll just reverse it. I don't know why I would do that now that I think about it. Okay. 2 style warnings. Oh, we were reversing the iter. Okay. Oops. Reverse ref. Reverse ref. Okay. This, right? Any warnings? Oh, head, you know, yeah, let's just, it only makes sense. Alright. Alright, let's see. Okay. Redefine. And test. Test.lisp. Okay. No warnings, please. Good. List iterator. Alright. Pass all of our tests. Beautiful. Beautiful. Alright, test list. T, perfect, perfect. And oh, we have one last one. Okay. Nice little way to cap it off, I guess, is alright. Yeah, I don't know what else would be expected there. Validate list. What the fuck? Alright, let's see what's going on here. Alright, let's see. This is starting to get kind of interesting. Alright, let's see. So we declare an integer of I. We do a list for each. We declare an element struct. Alright, we declare an element struct pointer. Oh shit. Fuck. Element is not a pointer in any of these others. Is that? No, fuck. Oh shit, okay. Alright, let's see. How do we use it? Okay, so I think it's... This is interesting. Alright, so walking through it, we declare a pointer to an element struct, and waiting list for each, so for each, let's go back to the util.h. Alright, so for the position of the element, okay. Alright, so for each element in the list starting with, or with head list, looking at the link members. Okay. So for each member, if I is greater than or equal to the length, we return 0. Okay? And then additionally, if e pointer I does not equal reference I, we return 0 again. Okay. Okay, this seems like what we're doing is essentially validating this part up here. So, let's see. I don't know what we need the E pointer for. I'm pretty sure that we don't need that. We probably honestly only need do we need a collection? No. We don't need the collection. I think we only need the iter. Okay. So at iter, a wailing list for each, and then we want to refer to these as elm again. Let's just go ahead and do it like that. We do need the collection. Fuck. Okay. I mean, yeah. Yeah, okay, yeah. FFI is weird. Okay. Yeah. think we're gonna have to have a result variable for at least this first part right here, since we're kind of nested. Yeah, okay. Or we could... No, that's too many layers. I'm not gonna do that. Is there a t value in Lisp, like one that you can actually use? I guess so. Yeah, okay, we're gonna use t then. Okay. What is the time check? Alright. Probably a bit more. You know, get this written, maybe part of the next test written. Wait, I can just check these. Right? No, because we want to print out the failure and return no. We want to do both. Okay. Yeah, because this is not a def test. Okay. Okay, perfect. Yeah. Right. Yeah, I'll just go ahead and do it. Why am I in caps lock? Or the other alternative is if the e pointer I does not equal reference I. Okay. And that'll be our end. So do we have a not equal? No. Do I have to do... Yeah, probably. Okay. Oh, so we're literally just doing this. Okay. Okay. That... kind of weird, but... you know? We ball. Set of res... no. So when either of these are true, we set that to no, and then if I does not equal length, if not equal, iterlen we will return nil here as well, else we will return the result. And that will, as I say, two birds, one stone. Let's slide this really quick. Evil normal state, okay. Alright. We have that. And these are the last two tests. Can probably at least get a portion of this one knocked out. This is the removal. So this is kind of where we're starting to get a little in the complex zone, which is good. In this case, def test list remove. All right. And then we will test list, make Wayland list, wait, what? And make wired tonight? What? What does this function even do? Steelbank C, make wired tonight. Alright. I'm probably not gonna get that last part done now, because well, what the fuck? Alright. Bank common list manual. Alright, let's check it this way. Trouble finding that site? What? The manual is available in HTML and PDF formats. Okay, there we go. Do they tell us about SBC? This is kind of nice. Oh, wait. Wait a sec. Wait. I'm already too deep in the CFFI, so also, it's a bit more portable, and then rely on Steelbank itself. SBCL supports the use of Lisp as a shared library that can be used by C programs using define alien callable interface. The callable exports keyword to save Lisp and die, or to save the Lisp image in a way that allows a C program to initialize the Lisp runtime and the exported symbols. When SBCL is built as a library, it exposes the symbol initialize Lisp, which can be used in conjunction with a core initializing global symbols to foreign callables. There's no way to run exit hooks or otherwise undo Lisp initialization gracefully from C. Oh, okay, that's nice to know. This section presents a complete example of an interface to a somewhat complicated C function. Alright, struct C struct, index char s, struct C struct C function. Alright, so yeah, we make a C struct pointer function. And this one has SRA. Oh, they're just naming the types down here. You know, this isn't too horrible looking. It mirrors the way of like the actual C in a way that is nice. Defun call cfun with alien array and c struct c struct. Yeah, yeah. Obviously that's return the name of c struct. I totally, you know, couldn't fucking be me. I couldn't. But what is? Can I look this up in the hyperspec maybe? Like, what are we? TN, you know, honestly, looking into the SPCL spec might be something really. It might be a good idea. But I'm wondering what this is. My initial thoughts, let's see if we can actually just describe this. Oh, unbound. Oops. Cribe is unbound. You're fucking up. Okay, there we go. Yes. Source file. Sys source compiler. Oh, this is part of the compiler. Oh, okay. It's not an FFI. Yeah, that would make sense too. But the fact that they have FFI is pretty cool actually, now that I'm looking at it. It's not horribly ugly either. Yeah, this... I mean, for something like what I'm working on right now, you know, I want it to be portable across multiple versions of Common Lisp, but this isn't too bad. For if I ever do want to do something that is specifically SBCL, this is pretty cool. Okay, that's enough of that. Let's at least get some of our let bindings defined, you know, in a proper manner. Alright. And then we're gonna be reusing these three. And coal as well, but I will get coal later. Alright. And references 1 and 2. Okay. $17,888, 1,000, and then ref 2 is 17 and 1,000. 1,000 there. Alright, alright, perfect. First thing we're gonna do is set Alright, 17, 88, alright, and 1,000. And we already ended the list, and then we are add the shit in as they say, so. Cool. Wayland list, insert, task list, and E1, yes. I keep forgetting that these are Lisp objects and not C structs. But you know what? We are learning. E2, and then E2, E3. And then we want to I just do T1. T is undefined. I could probably, yeah. No, because that'll just return nil. That's not going to return a failed test. Fuck it, this is returning a number. Fuck it. Yeah, we're returning a number for this. I return a number from this one as well. don't think this one has a res like this does. Yeah, it does not. Okay, yeah, we'll return a number. Alright, so we want to assert that we can validate the list with reference one, so validate the list. So, call reference one is ref one and oh, we removed something. Okay. Sick. Alright. And we're removing E1. No, we're removing E2. I can't read. And ref2 and the length of ref2. One style warning. What are you 3 style warnings. Wayland listens are called with 2 arguments, but once exactly 3. I did indeed call it with 2. Multiple times, in fact. My bad. Call. Alright. Call. Cool. Colon cool. Actually, I named it list remover instead of list remove. We ball. We error. We do not ball, we error. The value -1 is not of type unsigned byte. The value of -1 is not of type unsigned byte. So LM is DE113 and we call Wayland list remove the okay. Type error. I wish you would tell me what the Alright, so we're fucking up on the end Kadir somewhere in the removal. But I wonder exactly. Okay. Nth unavailable argument. Unavailable argument. Hmm. So previous position is the. So when there is a previous position, yeah. Alright. So let previous position -1 position element call. Alright? When nth, so nth returns, so we are indexing out of the list, it would seem. Alright, let's see. What we're gonna do is kind of walk through this one in the REPL. Yeah, we'll just go ahead and walk through this in the REPL really quick. And figure out the problem, and then once that's done, probably want to sleep. Probably want to do that right now, actually. Yeah. Let me really quick, let remove, okay. Yeah, this is quite, I don't know, you know, we'll run through a really quick test. We'll define this. Alright. Oh, oops. yeah, I'll deal with the memory being fucked up. I'll just restart my computer after this instead of having to deal with trying to dereference the shit at any point. But yeah, we are going to F5. Alright. Colon nil. Alright, so we want to element is in there. Element is in there. And element is in there. Failed. No. Fuck. So I wonder what the logic on this one would be that's making it fail. So we pass in the collection to the function. We pass in reference 1. And we pass in the length of reference 1, which is length ref 1. Oh, I'm not adding the other. Sick. Hell yeah. Is that really it? Alright. Unhandled memory fault. Alright. Bogus stack frame. That's the most unhelpful fucking... Okay, alright. We are... Let's go ahead and, walk through this. So we know we didn't try to remove from an empty list. Alright, so let the previous position be 1 minus the position of the current collection. So whenever we reach that, we want to let PRV be the nth minus 1 ln or e2 col so let previous be let previous be whatever was actually in that value. And then we want to set off the next in prev to the next in E2. If I could spell correct, that would so I think this is one of the problem lines, if not the problem line, because that's the one that comes after it. So that does work. So we know that this is the what's actually has that as a pointer. Alright, so that's the C struct for this one. It points toward itself. Head of the list points toward itself. Its next points ostensibly to this element. Wait, let's take one more look at that. Alright, 3410. Alright. Alright. Alright, alright. This one. Wait, its previous points back and its next points forward. So 3F0. Yeah. This one should point to 3F0 for its previous. Yes. So this part works. It's this part that is fucking up. Oh, I'm determined, but you know it's already 10:20. Already 10:20. And yeah, I probably need to like sleep. So I think what we're gonna go ahead and do is call it a good night for now, and yeah, catch some Z's. I do hope. I don't know. Yeah. I'll go ahead and do that. Maybe you should read. Nah, it's late. Is there anyone? It's you or nah. Okay. Bye.